This video was made possible by StruSoft.
When, for example, analyzing walls that have slabs connecting to them from only one side, eccentricity needs to be taken into account because it will increase the bending moment in the wall. You can edit the alignment and eccentricity of a plate by using the Shell Eccentricity.construct component. Connect it to the Shell Eccentricity input of the plate or wall component. In Rhino, I have a rectangle which represents the plate, a line that represents the support, and another line which is used for line load definition. This is how the model looks in FEM-design. The first input of the component is the alignment. You can select between center, bottom and top. They are easier to explain in FEM-design, so let's hop on to that. Here we have a plate. Here on the right, you can click on the physical view icon to toggle on a 3D representation of the element. I will open the properties and we can change the alignment here. Currently the plate is aligned to center. I will change it to bottom and you can see that the defining line is here and the slab is connected from its bottom. I will open the properties again and change the alignment to top. And now the plate is connected from its top. Let's head back to the wall example and see how this works in practice. Here I have set the alignment to center. I have run the analysis and we get no bending moments in the shell. I will set the alignment to top, rerun the analysis and navigate to results. The shell is now experiencing bending moments because the load is off-centered. Let's see now how the eccentricity works. If we have no eccentricity and we run the analysis, we get no bending moments in the wall. But if we add an eccentricity of 0.1 meters and rerun the analysis, we start having bending moments in our wall. The eccentricity can also take into account loads that are placed far outside the shell thickness. This would be the case if we had, for example, a concrete console attached to the wall. If we right-click on the wall and go to properties, we can see this nice image here that will help us understand how the eccentricity works and where it's calculated from. If our alignment is in the center, the eccentricity is calculated from the center. If it is in the bottom, it is calculated from the bottom. If it is in the top, it's calculated from the top. The consider eccentricity in calculation must be checked, which you can also do here with the grasshopper component. The last input is a boolean toggle for eccentricity by cracking. By toggling this to true and selecting cracked section analysis from FEM-design, you can take into account the change in stiffness when a concrete element cracks, but we will not cover that in this video.